Hey guys, it's a lab day. That's exciting. Today what we're going to be doing is looking more specifically at some of the different elements on the periodic table, looking at their physical properties and their chemical properties, and determining where on the table are metals and nonmetals and metalloids located based on those properties. So by this point in the lab day, you should have read through this already and completed this Venn diagram with the words down here. If you haven't yet, maybe pause the video and go ahead and do that. But that was something we did together. And now we're getting on to this portion. Again, the objective is written there. The materials that we're going to be using and working with, the elements that we're going to be testing are listed up here, as well as some of the other chemicals and materials. What we're going to do with each different element that we are exploring is describe the physical properties, what it looks like. We are going to be talking about the appearance, solid, liquid, or gas, and whether it has a shiny metallic luster or not. We will use a mallet to learn about its malleability, seeing if it shatters, if it's brittle, or if it just bends and changes shape, which would be something malleable. We will be testing its conductivity with our handy-dandy conductivity testers, and that will be some of the physical properties. Then we're going to look at some chemical properties, and that will be testing each substance with some copper chloride. It's a solution that we'll be working with, and some hydrochloric acid, and seeing how each material responds and reacts with that. So your data table is down a little bit lower, and I think that we are probably ready to get started. I'm going to leave it up to you to put the symbol for each, and we'll be talking about the physical description together and then doing these tests. Let's get started. All right, so the first element we are working with is sodium, and the first thing I want to point out is that sodium is stored in a special way. Sodium is very reactive with water, and so it's stored in this special canister to protect it from touching any water in the air. I'm going to pull my bottle of sodium out of that special canister, and inside here the sodium is stored under mineral oil. Since oil and water don't mix, it's figured as long as it's surrounded by oil, it can't touch moisture in the air. And then I'm going to grab a piece of sodium out of here, and we'll take a look and see what it looks like. So here is my sodium, just like this, and I'm going to set it down on a watch glass here so we can look at it a little bit more carefully. Thinking about what sodium looks like in its physical description, we noticed right away that it's a solid, and it does have this shiny metallic luster. Whether it's malleable or brittle, we can take a look at. I am actually able to smush it and shape it and cut it with my little tool here, almost like it's some butter that's been in the fridge for a while. So we would say that it is in fact malleable. Next thing we'll check and see is if it does conduct electricity. All right, I've got my conductivity tester here. And when I put my probes on the sodium, my light bulb does in fact light up. So sodium is a conductor. Okay, next we're going to see what sodium does when it is placed in some hydrochloric acid. And I'm going to do this one inside of a test tube because it is kind of a violent reaction. Actually, remember, it reacts strongly with water. Well, there is water in acid. And so what I'm going to do is just drop some in the test tube, and we'll see what happens. I'm actually going to hold a cover here close by so I can cover it up. And you'll see why I'm doing that in a second. So in goes the sodium. And there's a very strong reaction happening in there as the sodium reacts with the water. It's actually producing hydrogen gas, a lot of heat. So what's that called? Exothermic. And now the sodium has reacted with the acid, and it's all gone now. Sometimes it even flames up and shoots out of there. Since it's producing hydrogen gas, sometimes it'll get hot enough from the exothermic reaction to actually ignite the hydrogen. That didn't happen this time, and that's okay. Okay, and the next thing is we're going to see what sodium does when it's placed with copper chloride. So I'm going to tip this down. I've got this little reaction plate down here where we will put some, let's see, where did I put it? Right here. Just break off another little chunk and set it right in there. I've got this bottle of copper chloride. Ooh, that one ignited. Sweet, we'll just let that be. Hey, I've never had this happen before. It melted through my plastic thing. Cool. All right, and we'll be filling out that last column, metal, non-metal, or metalloid, at the end of the lab, or after we get through all the different elements. So the next one we're going to look at is carbon. Carbon, of course, is C on the periodic table. Got a little jar of it here. And we're going to talk about its physical description, and I think I'll set this down here on the paper towel so we can look at it a little bit. Basically, it's a black solid. When you think about carbon, you can think about things like graphite that's in a pencil, or charcoal that you might put on your grill. Those are all examples of pure carbon. Carbon can exist other ways too, like diamond is pure carbon. Just a different version of it. But the one that we've got here is just a black solid. Is it malleable or brittle? Well, let's see here. I'm going to try to whack this without hitting the camera. Whoa, went flying. Well, a chunk broke off. It's kind of malleable. It kind of shattered. But it's pretty tough. Did I say it's kind of malleable? I meant to say it's kind of brittle. So some chunks have broken off. I've got some other ones here from other experiments. It can be crushed. Now that it's been crushed into these small pieces, they would probably crush up easier than this full cylinder. But we'll call that brittle. And then the next thing that we'll look at is, does this conduct electricity? Well, let's see here. I've got my probe. And when I connect this on here, my light bulb is lighting up. It is a conductor. Carbon is. How does it react with hydrochloric acid? Well, let's see. I'm just going to take a little chunk and let's drop it in this one this time. And here comes some acid. And I'm not seeing anything, no reaction with the hydrochloric acid. Let's see about copper chloride. Funny thing just happened. I noticed that other bottle I had before wasn't copper chloride, it was calcium chloride. But I think it would have reacted the same with the sodium, but I was wondering why it wasn't blue like I expected. It's kind of this blue color is what copper is. And we're going to let that sit in there for just a second. I'm going to pause the video and then we'll take a look at it again. I think what I'm going to do is I'm going to let that carbon sit in there, and we'll take a look at it again towards the end. We'll see if there's any color change or anything. So let's go on to our next element, aluminum. You're pretty familiar with aluminum. You probably don't need me to show it to you. I've got some aluminum foil here, just from something that you can buy at the store. So it's obviously a very shiny metallic luster, and it is a solid at room temperature. Is it malleable or brittle? I don't think I even need to really pound on this with a mallet, because we can see that it's malleable because it's shapeable. You can bend it. And metals that are easily malleable, like aluminum and tin and some others, make really good foils like this. Easily pounded flat and shaped. Gold foil would be another example. Some metals, they are only more malleable when you heat them up, like iron, but aluminum is very malleable. Does it conduct electricity? Maybe it's obvious, but we better take a look anyway. Put my conductivity tester on. And it got lit. Must be a conductor. It is. Let me tear off a little piece and we'll put some with the acid and with the copper chloride. Going to put a chunk in each one. Here comes the acid. And I'm not noticing a reaction with the acid. I am noticing a reaction right away. Maybe you can see the bubbles in there and it's changing color. So we're getting a pretty obvious reaction with the aluminum. What's actually happening is the aluminum is swapping places with the copper that's in the copper chloride. So the aluminum foil is actually turning this coppery color as it swaps places. Copper is kind of getting deposited on that foil. And I wanted to take a look at the carbon here. I'm not seeing any reaction from the carbon from earlier. Or maybe just a slight reaction, a very mild reaction with the copper. Okay, let's go on to the next one. Next element is copper. It's not CO on the periodic table, it's Cu. CO is cobalt. And it's obviously another solid at room temperature. And I don't know how to describe the color other than coppery, right? It's kind of that reddish brownish color. And is it malleable or brittle? Well, on this thin strip that I have is malleable. I can shape it, and I could pound on it and shape it as well when it's thin like this. Huge hunk of copper I wouldn't be able to do as easily, but this thin one I can. Is it a conductor? Well, your house is probably wired with copper wires. Not probably, I know it is. Copper is one of the best conductors after silver, and the light bulb does light up just to prove it to you. Let's check and see what it does with some acid here. I'm dropping in my 2 chunks. First with the acid. Next with the copper chloride. With the acid, I noticed that it shined it up, but I don't think the actual copper is reacting. I don't know if you ever did any of those things in elementary school where you put some pennies in vinegar to shine them up, or in anything that's acidic like tomato sauce, salsa, ketchup. It'll all do it. So I don't think the copper is actually reacting. It just reacted with the impurities that were on the copper, the way it looks. And when I put the copper in the copper chloride, no reaction is occurring, which kind of makes sense once you learn a little bit more chemistry, because in this one the aluminum and copper swapped places. Well, in this one, if the copper swaps with the copper, you're not going to notice anything, so no reaction. Okay, the next pure element we have here is some lead. I've got some chunk of lead. I noticed right away it's dense. It's a very dense solid. It also has that shimmery, silvery luster. Not as shiny of a luster as aluminum. It's more of a dull luster, but it's still there nonetheless. Malleable or brittle? It is malleable. I can shape it and fold it when it's thin like this. If you ever have used any fishing weights with lead, you've maybe noticed they're malleable because you can use a pliers, or I sometimes use my teeth, even though I shouldn't, to put those sinkers on your line or to take them back off. And you're actually bending them when you do that. Whoops, I just tore some. Is it a conductor? Let's see if it is. Here we go, the tester's going on. And it also got lit. It is a conductor. How does it react with hydrochloric acid and copper chloride? Let's take a look. Here's a little chunk going in there. I'll put some acid and the other one. I would say no reaction with the acid. And with the copper, nothing yet, but we're going to revisit that one in a little bit too. But let's do our next element, magnesium. Okay, I've got some magnesium here. It is a solid at room temperature, and it does have kind of that metallic gray color. It's not real shiny, but maybe I'll take a little sandpaper to it and get off some of that oxidized layer that's on it. Okay, once I took the sandpaper to it, it did shine up a little bit more. I figured it probably would. And magnesium is bendable like this. We will call it malleable. Is it a conductor? Let's take a look-see. Here's my magnesium. Here's my conductivity tester. Got lit. It's a conductor. Magnesium is. How does it react with our two different solutions? Well, let me put a little chunk in each spot here. That'll be the acid. That'll be the copper chloride. With the acid, I am getting some bubbling and fizzing. That would be the hydrogen gas bubbles. And let me get a squirt of copper chloride to put in here with the magnesium. Hey, that one's also bubbling around. So I'm getting a reaction in both. In the copper chloride, it's also turning that coppery color just like the aluminum did, because the copper in the solution is swapping places with the magnesium. The next element we're going to look at is sulfur. I've got some in a jar right here, and we notice right away that it's a yellow solid. Something you might know about sulfur is it's stinky. Wait. Yep, smells like rotten eggs. If you've ever been to Yellowstone National Park, there's a lot of yellow sulfur in Yellowstone, and it stinks. As you're walking around and viewing the geysers, you can smell that sulfur smell in the air. Is it malleable or brittle? I'm going to pour a little bit out here on our paper towel. And it's already kind of powdery, but if I were to take a mallet, I can smash up those little pieces into even smaller pieces. So we will say that sulfur is brittle. Sulfur is brittle. Is it a conductor? Well, it's kind of hard to test it as a powder, but if it was a conductor, still my light bulb should light up, but it's not. Doesn't get lit. Sulfur doesn't. Let's take a look at what's happening with acid and copper chloride. I'm just going to take a pinch, put it with each. I can still see and hear the bubbling from my magnesium from before. Here goes the acid. Here goes the copper chloride. And I see no reaction in either one. So it acted very differently from some of the other things, didn't it? Let's look at our next material. Our next material is silicon, not to be confused with silicone. Silicone is sometimes something you buy at the hardware store in a tube and you squirt it around your bathtub and around windows and places that you want to make sealed and waterproofed. This is silicon. There's no E on the end. And let's take a look at the appearance a little bit. I'm going to pour some out again on my paper towel. It is a solid. and it is kind of silvery. It's got this silvery metallic luster to it, like this. And I am able to pound it into smaller pieces. So I would say it is brittle. Silicon is. Let's see what happens when I put it with some acid and copper chloride. Oh, I think I forgot to see if it's a conductor. Maybe I should do that first. Trying to look for one big chunk. My light bulb is not lighting up. So silicon is not a conductor, at least not a good one. Okay, now I'm going to look at what happens with acid and copper chloride. Going in this one. I'm seeing no reaction with acid and no reaction with copper chloride. So no reaction in either one. I want to go back to one that we did earlier. Thinking about the lead. I think the lead had a slow reaction. It is slightly discolored. So for lead, we could say there was a slow reaction, much slower than, say, the aluminum or magnesium. They were the fastest so far. My carbon still looks pretty black and no bubbles. Just to review those and make sure that they are what they are. Okay, so we've gotten through silicon. We're going to go to tin next. Okay, I have a small piece of tin foil. Tin foil used to be the standard kind of foil that you buy in stores. That's why some people, especially your parents or older generation, say, hey, put on some of that tin foil, even though it's really aluminum nowadays. It used to be tin that you would buy. So I have some of this tin foil, and it's a solid at room temperature, quite obviously. And we notice that it is very shiny, it has that shiny luster to it, much like aluminum foil. It's just a slightly different color, you would notice if you had them side by side. It is malleable because I can shape them, or shape this piece by folding it, bending it, etc. It doesn't shatter. Is it a conductor? Well, let's check it out. Here's my little piece of tin foil. Here's my little conductivity tester. Bing. It does light up. Tin is a conductor. Let's see what happens when we put it with acid. I'm going to start a new section here. Okay, right here. Can't believe I burned a hole in my plastic thing. I should have known better. Well, the tin with the acid did something kind of like the copper did, where it shined it up a little bit more and cleaned off the impurities, but I'd say there's no reaction actually happening with the acid. However, with the copper chloride, I think there is a slow reaction happening in here. It is changing color slightly, so it's maybe a little faster than the lead, but not as fast as, say, magnesium or aluminum. But we will say yes, there is a reaction with copper chloride. So that was tin, one element to go. The last element we're working with today is zinc, and I just have some small little pieces. It's kind of a thick foil. It does have that shiny luster. It is malleable. I can shape it. This one isn't as thin as some of the other materials we were working with, so it's a little bit harder, but I can bend it into different shapes. That could be helped by a hammer if I would like to. Let's see if it's a conductor. I'm going to reflatten this back out. There's my chunk. Better back this up a little bit. And putting my conductivity tester on there. And my light bulb does light up, you can see, when it's touching opposite sides of the zinc. And now we'll see what it does with the acid and copper chloride. There goes my zinc chunks. Here comes the acid. Ooh. Well, the zinc reacted very quickly with the copper chloride. You can see how dark it turned. I think the camera wasn't on it right when I set it in there, so I'm going to do another one. Starting out shiny, then when I drop it in, it turns dark very quickly. Again, the copper and the zinc are swapping places. And so there was a reaction with the copper chloride, and over here on the acid side, there are some bubbles slowly forming on the zinc. Those are those hydrogen gas bubbles forming slowly. So there's a slow reaction with the acid, but there is a reaction nonetheless. Okay, so we got through each of the elements in our little sample of the periodic table. Next, what we can do is answer some of the conclusion questions. And the first one says to describe or list whether it's a metal, nonmetal, or metalloid. If it has 4 or more metallic characteristics, it's a metal. If it has 3, consider it a metalloid. And if it's less than 3, consider it a nonmetal. So I'm going to scroll back up here. And we can think about metallic characteristics either by looking at this Venn diagram that we made, or this description right up here tells us also about metals and nonmetals in this paragraph. So you can use that to help guide you. I guess up here as well in this paragraph. Okay, and I'm just going to let you pause the video as you need, otherwise I'm going to just keep going through the rest of the questions and just talk through it a little bit. But you can pause the video as you complete each question. So number 2, how do the properties of these 3 relate to the element's location on the periodic table? So you might notice all the metals, all the things you considered metals, are kind of on one section of the table, and all the nonmetals are in a different section. So which side is which, and then where are the metalloids? You can use the P-Table website to help you. I know that that has some information about those things as well. So you can check that out. Again, I'll trust you to pause if you need some time. Otherwise, I'm going to go on to number 3. Actually, 3 and 4 are kind of self-explanatory. Just do a little bit of research on your own. And then we come to number 5. It says, consider this to be a mini periodic table model right here. I've got the 18 different columns listed here, but notice I squished groups or columns 3 through 12 all together into one spot. Okay, just to make it fit a little bit easier. You're going to be coloring the different groups different colors. You can use this link to help you discover where these things are. So for instance, when I click on this link and I'm wondering where are the alkali metals, this website will tell me where the alkali metals are. Alkali metals, well, they made theirs yellow. My instructions said to make them orange. Doesn't matter a whole lot. If you want to read about some of this information in the periodic table a little bit, this is fun reading for a chemistry nerd such as me, you. It's up to you if you want to read through this. You'll find a lot of the information that we've been talking about already in there. Okay, so you can use that website as you need to complete the assignment. And when it says color, just a little update about how you can do that. You can just select the column that you want and then go up here to your little coloring tool, and boom, just like that, they're orange. Sweet. And that is the end of the lab, guys, and hopefully by now you recognize which side of the table contains the different types of elements. And now some of the special groups. So it's not just that metals are on one side, but certain metals are in group 1, certain metals are in group 2, and 3 through 12, etc. And then there's also some special names for some of the other parts of the table, some of the non-metals, and that's listed on there as well. Hey, great job today, guys. Hope it was interesting for you, and have a great rest of the day.